Hello everyone, I am Dr. Vinay and today's topic is Bronsted and Lowry concept of acids and base. In last video we have seen Arrhenius concept, according to which we know that the substances which release H plus ion in the aqueous solution are acids and those substances which release OH minus ion are called bases. But we know this thing that many of the substances, the nature of many substances like ammonia, like Cn minus, this could not be explained by the Arrhenius theory क्योंकि वो OH नहीं निकालते हैं, but still we know that these are the very good base. Okay, now this theory is going to work for these type of limitations which are there in the case of Arrhenius. So now we will understand what this Bronsted and Lowry concept says about acid and base, how it explains acids and base. So let's see. According to Bronsted and Lowry concept, proton donors. Protons are what? Proton is H plus ion. H is what? Hydrogen. Hydrogen में से if I am removing one electron, what is left out? Only one proton. So actually H plus ion is nothing but proton. So according to this concept, H plus ion donors are acids and H plus ion acceptors are bases. So this particular theory speaks only considering H plus ion. So let's see some examples so you can understand it in a better way. So I am taking an example of ammonia because it was not explainable at that time, and I am reacting it with HCl. Okay. Now when these two react, ammonia converts into NH4 plus ion and Cl into Cl minus. Now just observe this ammonia. This ammonia turned into NH4 plus. Can you see the difference between these two? What it has done in this particular reaction? Ammonia has accepted H plus ion. So what are the acceptor of H plus ion called? Base. So I can write down that this ammonia is working as a base. In the same way, if I observe this HCl, you can see there this HCl is turning into Cl minus. And what it has done to turn into Cl minus? It has lost its H plus ion. So can you see there? H plus ion donor are acid. So because it has donated its H plus ion to the ammonia, that is why it is working as a acid here. So here in this case, base is ammonia because it has accepted the proton, and HCl is a acid which is donated the proton. Let's take one more example. Here I am taking ammonia this time and I am dissolving it into the water. So let's see what happens when ammonia is dissolved into the water. This ammonia is going to convert into NH4 plus and this water is going to convert into OH minus. Now let's apply the concept. Ammonia converted into NH4 plus. How it has converted into NH4 plus? By the acceptance of proton. So I will call it as base. Same. किससे लिया इसने proton? From water. So water has donated the proton. So what it is here? Working as acid. So in that way we are going to explain the acid and basic behavior of the various substances which are not having OH minus. So you can see here clearly कि all the Bronsted acids, according to Bronsted also H plus ion release करना is the property of acid substance. In the same way, Arrhenius के accordingly H plus ion का release होना is the property of an acid. So we can say that all the Arrhenius acids are Bronsted acid. But in that case, if we talk about the bases, all the Arrhenius bases are not the Bronsted bases. For an example, if I talk about sodium hydroxide, this is Arrhenius base, but it does not accept H plus ion. नहीं accept करता ना, तो it cannot be called as Bronsted base. Are you clear? So all the Arrhenius acids are Bronsted acid, but all the Arrhenius bases are not Bronsted bases because this is not compulsory that they are going to get the proton, because we are going to define our Bronsted and Lowry concept only in terms of H plus ion donation or acceptance. Is it clear? Let's move on. Now, next thing what you are observing here is that there are two pairs of acid and base here. They are present in the pairs, and these pairs we call as conjugate acid and base pairs. So very special thing about the Bronsted-Lowry concept is that they have explained the concept using the term called conjugate acid and conjugate base. अब conjugate acid and base क्या होते हैं, यहाँ पे ऑब्जर्व कीजिए. You can observe these are present in the pairs. For an example, if this is a base, it has accepted the proton and converted into a substance. Now look at these two. I am concentrating on these two. This ammonia is converted into NH4 plus. Now can you observe this thing? Now this ammonium can lose the electron to convert into the ammonia. So when it will lose the electron, it will have the tendency to become, to behave like a acid. So it is an acid of ammonia. So you can say that when this was a base and accepted the electron, it has converted into a acid. So this pair, which is differing from each other by the H plus ion only, is called conjugate acid and base pair. So every base after the acceptance of proton is converted into an acid, because now it is having a plus ion, H plus ion. So it can donate. So ammonia is an acid, ammonium ion is an acid, which is called the conjugate acid of this base. So these are the pairs after the acceptance and after the loss. Whatever the relationship is being created, that is called conjugate acid and base pair. Let us understand it in another by giving another example. So I am taking this time HCl. So look at this HCl. This HCl has converted into Cl minus. Now after the loss of H plus ion, because it has lost, it is an acid. After the loss, it has converted into a base. क्योंकि अब तो ये accept करेगा ना. अब ये base क्यों है? Because now it has a tendency to accept the H plus. So this acid and base pair is known as conjugate acid and base pair. And every acid has a conjugate base. मतलब after the release of H plus ion जो बचेगा वो बचेगा conjugate base. I am writing down conjugate. Conjugate का मतलब होता है connected, which was earlier connected with base. So those two species, two acid and base pair species which were connected with each other are called conjugate acid and base pair. So do understand that one base is converted after the acceptance, base is converted into acid, and after the loss, acid is converted into base. Okay? Let's take one more example by considering this. That is, here in this case, ammonia is a base, obviously, because it is accepting the electron and converting into NH plus. Once it is converted into NH4 plus, यही बात हम लोग यहाँ पे कह रहे थे. Once it is converted into NH4 plus, now it is a acid. क्योंकि अब ये दे सकता है ना, इसके पास एक H plus extra है. ठीक? Same. It is an acid here just because it has given its one electron, one proton to the ammonia. तो ये acid है. अब after this giving, what is H2O converted into? It has converted into OH minus. Now will this give H plus ion now? No. It will have the tendency to accept H plus ion. So water, which was an acid in this case, is now converted into OH minus, which is a acid, which is a base now. So this is conjugate base of H2O. This is conjugate acid. Conjugate का मतलब है connected. इसका base, इस base से connected ये acid है, and इस base acid से connected ये base है. So these pairs are called conjugate acid and base pairs. If you don't understand it, let's take one more example. So this time I will take a very simple example. Acetic acid, dissolution of acetic acid. Let's see. CH3COOH is reacting with the water, or I can say that it is going to release H plus ion. CH3COO minus will be formed and H3O plus ion. Simple reaction. In this reaction, we know that this is an acid. Why? Because it is going to release H plus ion. But देने के बाद how it is going to convert into? It is going to convert into CH3COO minus. So this is an acid, Bronsted acid, because it releases H plus ion. So it is proton donor. but after the donor it converts into this. So whatever is left out after the donation is a base. Why? Because it is not going to accept. ही क्यों देगा? Because it is not having that H plus ion in excess. तो ये अब accept करेगा. That is why it is a base. क्योंकि ये इससे बना है. That is why it is a conjugate base of acetic acid. So if I am telling you, write down the conjugate acid. Write down the conjugate acid of CH3CO minus. You can understand this thing कि इससे connected acid कौन होगा? जो acid H plus दे सकता है. तो कौन होगा acid कौन दे सकता है H plus? CH3COOH. Just add H plus to it. Just add H plus to it so that it will convert into acid. Add the H plus. So base को acid बनाने के लिए you will add H plus to it. Acid को base बनाने के लिए you will remove H plus या you will allow them to donate H plus ion so that they will convert into a base. So this is called acid and conjugate base. फिर देखते हैं H2O. Again H2O because it is acid, it is giving the electron. तो किसने लिया electron? H2O ने. तो this time it is a base. So you just don't consider acid and base by looking at the examples. जैसे कि in last example we have seen that water was working as a base क्योंकि वो H plus ion it was working as a acid because it was giving H plus ion to convert into OH minus. But यहाँ पे क्या हो रहा है? This is working as a base. Why? क्योंकि the product is H3O. तो how it is formed? Base. Base है तभी तो it has accepted H plus ion to convert into H3O plus. क्यों? So this is base. And just because it is converted into H3O plus ion और अब ये क्या करेगा? H2 plus ion तो देगा ना. It is H plus ion. It is having the H plus ion extra. तो this is a conjugate acid. इसका तो conjugate acid and conjugate base. तो one more thing you must be realizing here कि water can work as an acid as well as a base. So if I am having water and I release H plus ion from the water, what I will get? I will get OH minus ion. So here in this case, this water is working as a acid और इसका conjugate base क्या हुआ? Is OH minus. But water can behave in another way also. Water can accept the H plus ion also, and in that case, what will be formed? H3O plus. Up just because it is accepting the proton here, it is a base because according to Bronsted and Lowry concept, acceptors are bases. तो जब ये base है, तो after the acceptance, it will become acid. So this is the conjugate acid of this water. So if this water is working like both acid as well as bases, I will call this water as a type of substance, a special type of substance called amphoteric. What it is called? Amphoteric substance. This is going to behave like an acid as well as base. I hope it is clear to you. So let's see some more examples of amphoteric acids which can behave like an acid as well as like base. I am not rubbing this definition here. I am not rubbing this so that you can see to it clearly and you can identify acids and base. So now this time I am taking amphoteric substances. So here are some examples. I am starting from HSO4 minus. Now, can it give the electron? Yes, it can give. Can it give the proton? Yes. When it loses the proton, it will turn into SO4 2 minus. Just do one thing. H plus ion बाहर कर दीजिए. जैसे ही you will remove H plus ion, one more minus charge will appear क्योंकि 1 plus H is satisfying its 1 minus. 2 plus if you are removing one more, so there will be minus 2 charge on it. Now just imagine, can it gain plus ion? Yes, it can gain 1 plus ion. क्या तो बनेगा था? It can convert into H2SO4. So this HSO4 minus species will be named as amphoteric species because it can gain to form this H2SO4 and it can lose to form SO4 minus 2. ठीक है? एक और एग्जाम्पल लेते हैं. HS minus. Can it lose the proton? Yes, if it lose one proton, H H plus निकाल दीजिए, one more charge will appear on the sulfur, so it will convert into S2 minus. ठीक है, तो जब ये लूज करेगा तो it will convert into S2 minus, and that time when it is losing its plus electron या when it is donating its plus या H plus ion, it is working as a acid. So in this case it is working as a acid, but can it gain proton? Can it gain proton? Yes. When it gain proton, it will convert into H2S. एक और H plus आया तो इसका ये minus will be just nullified. ठीक है. So this is how it is converted into H2S. Fine. Now you can understand here. It can behave like acid by loss of proton. It can behave like a base by the gain of proton. That is why it is amphoteric in nature. Not only this, we have one more species. Let's see the example of HCO3 minus bicarbonate ion. Can it lose the proton? Yes, it can lose the proton. After the loss of one proton, it will convert into CO3 2 minus. Can it gain the proton? Yes, it can gain proton. और जब ये एक accept करेगा, that time it will convert into H2CO3. So it is working as a base here because it is accepting the proton. It is working as an acid here because it is losing the proton. Hence, it is these all species, this, and these type of species which have tendency to behave like an acid by the donation of proton, as well as like a base by the proton acceptance. That these type of species are known as amphoteric species. Is it clear? Now one thing we have to understand here, that whenever we talk about the conjugate acid base pair, conjugate acid and base pair are differing from each other by only H plus ion. Okay, so you don't need to bother about anything. If I am asking you, write down the conjugate, acid, मैं अब क्या बनवा रही हूँ आपसे, conjugate acid of HSO4. तो जस्ट इमेजिन कि मुझे एसिड बनाना है तो मुझे उसमें H प्लस चाहिए, तो आई विल जस्ट ऐड H प्लस आयन. तो व्हाट विल बी द conjugate acid of H plus HSO4 minus H2SO4 is the conjugate acid of HSO4, because they will differ from each other by H plus ion. जिस पे H plus ज़्यादा है that is acid, जिस पे H plus कम है वो base. Do not compare two of the different species in the different cases. As the case will differ, your species, your conjugate base and acid pair will differ. So don't compare the species. You just concentrate on the species with which they are talking about. तो अगर मैं इस पे concentrate कर रही हूँ तो इसका conjugate acid तो यही है. And if I talk about, write down the conjugate base of HSO4. HSO4 का conjugate base. अब मुझे base बनाना है. मुझे बेस कब बनाना है, कब बनता है बेस, व्हेन द एसिड रिलीज इज H+. तो इसमें से H+ निकाल दो, तो व्हाट इज फॉर्म्ड, HSO4 में से इफ यू हैव रिमूव्ड H+, व्हाट इज लेफ्ट आउट, SO4 2-. तो ये क्या हो गया, नाउ दिस टाइम इट इज रिलीजिंग H+, इसका मतलब है इट इज एसिड, एंड जस्ट बिकॉज इट हैज रिलीज्ड एंड व्हाटएवर इज लेफ्ट आउट is conjugate base. तो ये इसका conjugate base हो गया. तो you don't bother about anything else except you concentrate whatever the species is given to you. जो भी दिया हो, you just concentrate that species और फिर देखिए उसमें H plus ऐड कीजिए. अगर मैं acid चाहिए तो acid में add, you can learn it in this way only, add H plus if you want to make it acid and remove H plus if you want to convert into base. I hope it is clear to you. It's very simple to understand that we can now easily identify which is a conjugate base and acid pair. ठीक है. Now let's solve one question related to this particular topic and tell me what are the conjugate acid and bases pairs in this particular case. So I am taking an example. Now tell me CO3 2- is the species. You just tell me the conjugate acid of this CO3 2-. Conjugate acid I am asking. कॉन्जुगेट एसिड कैसे बनाएंगे? दे डिफर फ्रॉम ईच अदर बाय H प्लस, तो बस उसमें H प्लस जोड़ दीजिए। लुक इट, अगर आपको H प्लस जोड़ेंगे तो आपको मिलेगा एसिड। आई एम आस्किंग यू राइट डाउन द कॉन्जुगेट एसिड ऑफ कार्बोनेट आयन। तो आप एसिड बनाएंगे तो क्या करेंगे? कॉन्जुगेट एसिड बनाने के लिए जस्ट ऐड HCO3 एंड व्हेन यू आर एडिंग H प्लस नॉट H प्लस ऐड करेंगे तो 1 माइनस विल बी रिमूव्ड because it is 1 H plus is nullifying 1 minus. So this is HCO3 minus. The conjugate, this is what? Base. Q, because it is accepting H plus. Now this is what? Conjugate acid. After the acceptance, so whatever is species is formed after the acceptance, that is called acid. ठीक है? Now it has tendency to lose also. करके देखें, तो अगर ये लूज करेगा, एसिड लूज करेगा तो क्या बनाएगा? CO3 2 माइनस, ये इसका बेस हो गया। ठीक है, क्योंकि इट इज गोइंग टू लूज तो ये एसिड है, इट इज गोइंग टू गेन तो इट इज बेस। ठीक है, तो दिस वे यू कैन इजीली फाइंड आउट व्हाट इज एसिड एंड व्हाट इज बेस। एक और एग्जांपल लिखिए, O2 माइनस। जस्ट टेल मी द कॉन्जुगेट एसिड ऑफ O2 माइनस। एसिड बनाना है, जस्ट ऐड H प्लस आयन। H प्लस आयन ऐड करेंगे तो HO एंड हाउ मेनी माइनस विल रिमेन? 1. तो क्या मैं ऐसे लिख दूँ? OH माइनस। So can you understand this? OH minus is the conjugate acid. Don't consider कि OH तो base होता है. Conjugate, it is not. I'm not telling you that it is an acid. Conjugate acid it is. ठीक है? So OH minus is the conjugate acid of O2 minus. ठीक है? एक और एग्जाम्पल लेते हैं, OH minus का conjugate acid लिखिए। Write down the conjugate acid of OH minus ion. तो क्या करना है? Just add H plus ion. तो I am adding H plus ion. कैसे ऐड करूँ इसमें H plus ion? H2O. So this is acid and this is base. Conjugate acid. Conjugate acid. You can just don't write down acid or base. Write down conjugate acid. This is not acid. This is conjugate acid. So we are talking about in the pairs. These are related. In terms of their relation, we are defining this conjugate acid and base pair. We are not explaining you here कि ये acid है या ये base है, नहीं. We are just explaining you इन दोनों के relation में इसका connected base या इसका connected acid क्या है. तो that connected acid or base are called conjugate acid and conjugate base. Now we have seen that many of the things are being explained by this particular theory, but some of the things are left out. For an example, this theory could not explain the acidic behavior of some compounds like aluminum chloride, BF3 kind of compounds. So this is not being explainable. This is not being explained by this Bronsted and Lowry concept of acid. हम सबको पता है that this is a acid, Lewis acid. So these are the Lewis acids. So Lewis is going to explain this. So in the next video we will be discussing Lewis acids and Lewis base concept, which can explain even the behavior of this AlCl3 and BF3 as a acid. Same way, this Bronsted-Lowry concept could not explain what? It could not explain the basic behavior of CaO, यानी कि basic oxide, like MgO, which is a basic oxide, like NaO, which is a basic oxide. On the other hand side, the acidic behavior of sulfur dioxide, acidic behavior of nitrogen dioxide, because they do not accept or do not lose protons. So these are the some limitations of this Bronsted and Lowry concept, but it can explain many of the things which were not explained by the RNS concept. Now I hope you are clear that conjugate acid and base pairs are differing from each other only by H plus ion. So do remember, whenever you are converting any compound, any substance into its conjugate acid, just add H plus. If you want to convert any substance into a base, just remove H plus. That is the only thing you have to do. Now one very important thing which I forgot to discuss here in terms of conjugate acid and base pair, that is strength of acid and base. Conjugate acid and base pairs are opposite to each other in their strength. For an example, if HCl react with water to give H3O plus and Cl minus. this HCl is an acid and this Cl is its conjugate base. Okay, now this water is a base. Why? Because it is what? It is going to gain the proton. So this is conjugate acid of water. Okay, so this is acid, इसका conjugate base, this is base, इसका conjugate acid. Now one thing which has to be mentioned here is, look at this. In this acid and base, HCl to Cl, in this acid and base pair, you have to remember, if your acid is strong, the base, conjugate base of that acid will be weak. For example, we know that HCl is a very strong acid. In this case of HCl, we know this thing very well, that HCl is a very strong acid. Very strong acid का conjugate base will be weak base. So the base formed will be weak base. Just understand it in this way, that this HCl is an acid because this H plus ion has been released from the HCl. किसने छोड़ा HCl में से H? This Cl minus. So this Cl minus has tendency to lose its proton, the proton connected with it. तो क्या this tendency of this chloride ion will be there to accept the H plus ion? आप जिस चीज़ को आसानी से छोड़ देते हैं, क्या आप उसको लेना पसंद करते हैं? Obviously not. If I like this thing, I will never leave it. If I have the tendency to throw something, to leave something, it means I don't have that much attraction about that thing. So what is a good base? The good base is that which has the tendency to accept the proton, and the more is the tendency to accept the proton, better is the base. So if it loses the proton very easily, it will not gain the proton that easily. इसका मतलब है, if it is a good acid, इसका conjugate base will be a weak base. I hope you are understanding this. So always remember, the conjugate acid and base pair में से if one is strong, another one will be weak. ठीक है? So we can recognize it. Look at this base, H2O. We all know this thing. Again, we know this thing so that we can explain it very easily. Water is it is not an acid, neither it is a base. हम सबको पता है कि water is neutral type of substances, but depending on the condition, it is behaving like a base sometimes, or it is behaving like a acid sometimes. So I am taking the example where this is working as a base. In this case, where it is turning into H3O plus ion. So यहाँ पे it is acting as a base, and now this is conjugate acid. Okay, we know this thing, this is H plus ion. We know this thing कि H plus ion तो itself it is an acid. So it is a very strong acid. Obviously it is H plus ion itself an acid. So if this is a very strong acid, इसका base will be a weak base. क्या मैं ऐसे बोलूँ? Because this water is a weak base, we know that water is a weak base. It is neither it is a good acid nor it is a good base. Because water is a weak base, इसका conjugate acid will be a very strong acid. Is it clear? Let's take one more example to make this concept of acid and base very clear. CH3COOH reacting with water to give you CH3COO minus and H3O plus. ठीक है? Now in this case also CH3COOH, we all know that this is an organic acid and it is a weak acid. After the removal of H plus ion, it is turned into base, and this is a conjugate base. It is not a base. Do remember, it is a conjugate base. इससे connected base. These are the conjugate acid base pair. So beta, how many pairs are there in a particular reaction? One pair, second pair. So this is conjugate base of this acetic acid. Fine. If I am declaring this thing that this is a weak acid, then the conjugate base of weak acid will be a strong base. Okay, so it will be a strong base. Now, इस बात को आप ऐसे समझिए that this acetic acid does not release H plus ion in more amount. It means it does not have the tendency to lose H plus ion. Now, anyhow, it has lost its electron and converted into acetate ion. Now, just because of that loss, it is already in trouble. उसको लगता है कि नहीं मुझे नहीं देना था. Now it is having this looking for कि कहीं से मुझे H plus ion मिल जाए तो I'll take it. So it is having a very strong tendency to gain the proton. It is looking for the proton क्योंकि इसने छोड़ा नहीं था आसान से. अब it is going to gain the proton very easily. That is why it is going to work as a strong base. So do remember, strong acid का conjugate base weak, weak acid का conjugate base strong, strong base का conjugate acid weak, weak base का conjugate acid strong. So in short, I can say that in conjugate acid and base pairs, if one of the part is a strong part, तो another one will be the weak part. Never it can happen that both of them are strong or both of them are weak. So always remember that weak and strong connect with each other to form a acid base pair. So this is all about conjugate acid and conjugate base according to Bronsted and Lowry concept. I hope this video will be helpful for you to differentiate between acid and the base part of the conjugate pair. So if you like this video, please hit the like button, share it and subscribe my channel. Thank you very much.